Okay, yeah, it works quite well. Hello, everybody. My name is Eric. I think we are going to start shortly. I'm very happy to be with you today in Minsk. It's my first time in your nice country. I hope I will have time to discover a little bit. And I'm going to talk about risk-based testing. The goal of my presentation is to show you that this method is very easy to use, and I hope that you will try to use it after this presentation. Before introducing briefly myself about you, what I know about you is that I don't know you, actually, but I guess you are all more or less interested in software quality and testing. And I think that in the room we may have many people with positions like business analyst, project manager, test manager, technical tester, functional tester. Yes, only one, one tester. And salesperson, so we may have 90% of salesperson. No, I don't know. Who would be considered as test manager or tester in the room? Okay, so that's good. Most of you. Okay, perfect. So a few words about myself. So I'm Eric Riou du Cosquer, a strange French name. I come from Paris in France. And I've been involved in software quality and testing for quite a long time, operating in different companies, small tool vendors, and also large companies in insurance, banking, telecommunication. And I'm also involved in several associations dedicated to software testing, like the ISTQB. I'm sure you've heard about the ISTQB. And also, the last one mentioned here is TMMI, which is a system very useful to assess not individuals, but to assess test organizations. So I've been doing that for a long time, and that's quite interesting. So today I'm going to speak about risk-based testing. That's not new. But I think that in that kind of conference, it's very good to have new topics, funny topics, to get idea. But it's also very important to, from time to time, remind you that the basics of testing are still there and are still very efficient. So risk-based testing is one of the basics. That's something easy, something important. And I will briefly show you how it works. And I hope you will be convinced that it's a useful technique. So today I will start with a brief introduction about the basics of risk management, the basic techniques, and then I will show you the RBT approach, which is very useful to go further actually and to be more efficient with the risk-based testing management. So the first stupid question today is, what is testing? It really sounds like a stupid question, but when I ask this question on the project, and you may know that, the first answer which comes is, well, testing, it's designing test cases and executing test cases to see if the application works. So that's part of the testing. But what I just would like to remind you is that testing is not only test design and test execution, it's a set of several activities. You may know most of them. So of course, in these activities, we've got implementation and execution of test cases, but we also have things like test planning and control, which is more like project management activities. We also have reporting, evaluating the results. So the message is, keep in mind that testing is not just designing and executing the tests. And these activities, second important point, have to be implemented at different test levels, at different stages, different phases of your project. From the technical part, which is called component testing, the component level, mainly addressed by technical developers, technical people. Then we have a second level, which is called integration testing. Then a third one, which is system testing. And the last one, which is acceptance testing. So I know that most of you already know that, but it's important because what we will see is that the risk-based testing approach is everywhere in the test process, in each activity and at any level. And on the top of that, it's also useful, as you may know, to have like a high-level test management described in a document that we could call the master test plan. And it's very useful to have an overall view on all the test activities on your project. Okay, so that's a brief introduction about testing. You know that. Then regarding the risk, what is a risk? A risk is something that might happen. We are not sure that it's going to happen, but what we are sure about is that if it happens, it will bother us a little bit or a lot. It may make us lose money. It may injure us. So that's very important to think about these risks. And it's also very important to be able to make the difference between what we call project risk, mainly addressed by the project managers. Do I have enough money for my project? Do I have enough time? So that's the first type of risk. And today I'm not going to talk about this project risk because it's not really part of the risk-based testing approach. The second type is the product risk, which are clearly associated to the quality of the product you are going to test, software or application or system. And that's what risk-based testing is about. It will be addressing product risk. And risk-based testing is like an approach, like a strategy. I guess you know that there are several possible strategies to manage your test activities on the project. One of them, for example, is the specification-based strategy. It means that you take as input all the normal documents on your project, functional specification, technical design, requirements, and then you will create test cases to cover these requirements. And risk-based testing is another approach. Instead of starting only with the specifications, only with the documentation, you will try to create like a risk repository, and this risk repository will be the basis to create additional test cases and to follow up the testing activities on your project. So, regarding this risk management process, as I said before, I will start with the basic approach. You may know it. You may don't know it, so it will be a quick overview on the process. And then I will come back to the main steps and show you how we can go further with the risk-based testing. Okay, so the risk management is basically a set of 4 main activities distributed between risk assessment and risk control. The first activities are identification of the risk, then analysis of the risk. Once we've got that, we have a risk repository, and we can use it to mitigate the risk and to monitor the project against the risk. So at the end of the first phase, risk identification, what do we have? Well, that's very easy. We have a list of risk. So a list of negative things that might happen on the project. And for each risk, we need to have at least a brief description and maybe the owner of the risk and the person who initially identified the risk. So that's risk identification. Then the next step is the risk analysis. And the goal of this second step is to assess for each risk the likelihood. Is it very, very likely to happen, or is it not very likely to happen? Likelihood and impact of the risk. What is the impact if the risk really occurs? And when we start doing this risk analysis, we very often use this kind of table to assess for each risk a level, and then depending on the level of the risk, we are going to put more or less effort, more or less test effort on the risk. So, for example, if you have a risk with a very low impact and a very low likelihood, you're not going to do anything with the risk. You're probably going to remove it from the list. And on the other side, if you've got a very high impact and a high likelihood, you're going to put a lot of effort on the risk. That's obvious. And about risk mitigation, so the goal is to control the risk. There are 4 main options to manage that. The first one is to mitigate the risk. It means that we are going to start as soon as possible to implement actions to limit the likelihood of the risk. For example, if you are working with a supplier in charge of developing the component of your application, and you consider that the development quality, the quality of the software development is a risk, you can mitigate this risk with static code analysis carried out very early in the project on the supplier side. The second option is to make contingency plans to reduce the impact. So the goal is to answer the question, what will we do if the risk occurs in production? For example, if the software sold to the customers doesn't work, the customers will complain, and we know that we will be able to offer them a gift for Christmas to make them happy. Another option, which is the third one, is to transfer the risk to someone else. So it's a bit like I'm not responsible for the risk, but I will find someone who will be responsible for the risk. It may be another company, another colleague, another entity of your company, and it may also be a system like an insurance of the risk. And the last option, option 4, which looks like the easiest, is to decide not to do anything with the risk. So deciding to do nothing is a decision, actually. It looks very easy, but it happens. The following situation happens quite often, actually. Sometimes you have a risk, and you know that it will be more expensive to try to mitigate the risk than dealing with the risk if it occurs in production. So in that case, okay, you see there's a risk, but you decide not to do anything. Okay, so that's really the basics of risk management. It's not risk-based testing. We can start thinking about risk-based testing when we try to associate test cases to the risk. And it's what we're going to talk about with the RBT approach. Okay, and the last step of the normal process is to monitor the risk. It means to deliver reports based on the risks. How many risks do we have? And for each risk, what is the value of the updated impact? What is the value of the updated likelihood? Who is working on the risk? And so on. And that's actually very, very important. I see many projects where people start the project with many time. They are very motivated, so they decide to manage the risk. But then, once they are very busy with their daily activities, they forget to monitor and to update the risk repository. So that's a shame, because in that case, it's not helpful at all. So that's very important to continuously assess, monitor, and update the risk repository. Okay, so that was really the basics about risk management. And we are now going to have a look at this RBT approach coming from PRISMA. PRISMA is a method which was defined by an ISTQB colleague called Erik van Veenendaal, who is one of the authors of the TMMI model. And he described this method in a small book, which I will show you at the end of the presentation. And it's really very well explained, very easy to use. So what we're going to see is, I would say, like a summary of this method. And you may have additional questions that you can raise to me at the end of the presentation. And if I cannot answer all your questions, you will find the answers in this very, very good book. Okay, so we'll have a look at the main steps, about 10 steps. And my goal, as I said before, is to show you that it's very easy to do risk-based testing. Very easy, you just have to follow the steps and to try on your project. The first step is, not the easiest one, is to make the decision to use the RBT approach. So you first need to be convinced by yourself that it's going to be useful on your project, and then you may have to convince your test manager or your project manager that it's necessary to allocate time and money, because time is money, to allocate money to this risk-based testing activity. If you don't know how to proceed, my advice would be to remind everyone the basics of testing. First, that it's not possible to test everything. So you will have to select a subpart of the application, a subpart that will be tested. And with the risk-based approach, you will be able to select and to clearly identify the most risky areas of the software. So it's very useful. The second point is that it always happens to have a budget cut during the project. You were expected to have 100 days of testing. You will only have 50 days. So you have to know what to do during these 50 instead of 100 days. And if you're able to select the test cases associated to the most risky parts of the software, you will not feel uncomfortable if you don't have all the time you wanted to have. The third point reminds us that, unfortunately, specification and requirements are very often of low quality, or it very often happens not to have enough requirements and enough specification. So it's very useful to have something else to build the test cases repository. You can build some of your test cases based on the specification and the requirements. And in addition to that, it's also very useful to build test cases based on the risk analysis. And the last point is about the customers. As you know, it's very important to satisfy the customers, to answer their real needs. And we will see that in the RBT approach, customers and final users, representatives, will be involved in the process. So that's also a good reason to explain why RBT should be useful. Okay, the second step is to identify the right people to be involved in the process. You have to involve people from inside the project, like the project manager, test manager, developers, technical designer, and you also have to involve people who are outside your projects, like the final customers. You also have to think about what we call external stakeholders, like standards or regulation laws and so on. So at the beginning, you have to see who will be able to provide you with relevant risks. And in the PRISMA approach, there's a checklist which can be useful if you don't know exactly who to ask to participate. There's a checklist of different kind of people who are supposed to be useful to help you to create the list of risk, like the client, usability experts. Usability is a non-functional characteristic which we sometimes forget, unfortunately. You may also ask the marketing representatives about the risk. They will be relevant to assess the potential impact on the users, for example. So you have this checklist, you have your knowledge of the project, and it will be helpful to identify the right people to be involved. Then, once you have the people, you will be able to start the identification phase of the risk-based testing process. So the goal is to identify a first set of risks and to create a list with this risk. How to proceed? There are different options. You can analyze the requirements if you've got some requirements. If you're working in Agile, you may just take as input the product or sprint backlog to see the expected features of the software. You may also organize interviews of the main stakeholders to collect their ideas about risk. And it's also very useful to organize brainstorming sessions and workshop with people with different skills to identify the risks to be taken into account. So at the end of this stage, you have here again a list of risks, and this first list will be then improved to put in place the RBT method. So that's actually the fourth step. You have to be sure that the list is not too large and that the risks that remain in the list are relevant. A question that we often get when we start implementing the RBT is, what is the difference between a risk and a requirement? Is it the same or is it different? And what we can see is that there are different options. We may have a risk, and when we analyze the risk, we don't see any corresponding requirement. So there are two options. It may signify that we have forgotten a requirement. In that case, we can add one or a couple of requirements and link them to the risk. And the other option is that the risk is not relevant, so we remove the risk. And on the other side, we may have a requirement which we cannot link to a risk. So in that case, two options again: creating a new risk to cover partly the requirement, or removing the requirement, because if there's no risk at all associated to the requirement, it may mean that the requirement is not useful for the final customers. So there's a real link, a real traceability between risks and requirements, and I would say that a risk, a specific risk, should normally be associated to a couple of requirements, between 3 to 10 maybe. We've got here a basic example regarding the ATM, which is always a good study case. If we take, for example, the third line, the system is unavailable to the customer for longer than 2 hours, so that's a risk. And this risk is not detailed enough to be considered as a requirement, so we will create one or more requirements corresponding to this risk. For example, the system shall be available to the customers 24 hours a day, each day of the week. So you can see the link between risk and requirements. Then, at the end of this fourth step, you have a relevant list of risks, and you can move forward with the risk analysis. The goal will be to firstly assess the impact of the risk, and secondly, to assess the likelihood of the risk. So you may think that there's nothing new compared to the traditional approach. You're partly right. What is new in this approach is that you will be supported in this impact and likelihood assessment with a set of predefined factors suggested to you to assess impact and likelihood. Impact, what we have in the PRISMA approach is 5 factors to be studied and which are directly related to the impact of the risk. The first one is about the criticity of the corresponding areas. What will happen if the risk occurs? Are we going to kill people or to make people lose a lot of money? Is it very critical? The second factor is about the visibility of the corresponding areas. If the risk occurs, is it going to be visible from outside the company or not? And we have like these 5 factors. Each factors should be rated, assessed for each risk. And it may be useful to weight the factors. You can consider that in your project, one of them is more important than the others. It's also possible to ask several people to rate the same risk. There are many ways of using that. Then you will do the same with the likelihood. Same approach with different factors. The factors suggested by PRISMA to assess the likelihood are complexity, size, new technology and not. Interfacing, it means number of interfaces related to the risky component. And what we can see here is that these factors are mainly, I would say, technical factors. I mean that they will be properly assessed by people with a technical knowledge and background. So that's for likelihood. Once this exercise is done, you have all what you need to create the risk matrix. The risk matrix is the place where you will put the risk to have a visual understanding of their criticality and their level. So you will have for each risk a value for the impact, a value for the likelihood. It can be managed in a table like this, in your favorite Excel sheet, for example, there's no problem. And then you can represent that in the risk matrix. And the suggestion of the method is to have 4 areas where you will place, where you will position the different risks. And then we will start working on this matrix. A brief comment is that very often when the impact is very high, it's a business risk because there are financial aspects behind. And when the likelihood is very high, it's very often a technical issue, a technical risks. When you do this matrix, you have to be careful. There are different common mistakes that often happens. The first problem you may face is to have many risks in the middle of the matrix. So that's not very good because in that case, you don't have a way to prioritize the risk and you don't know clearly which one is more important than the others. So if you've got this situation, you have to reassess the risk and try to make them be everywhere in the matrix. The second risk you may have is to have well, the second issue you may have with the risk is to have many risks in the same area of the matrix. And here again, if you are in this situation, it's not going to be very easy to use, so you will have to review again the risks. And the last situation you may face, particularly when you work on safety critical application like in the medical industry or avionic, automotive, we often have risk with a very high impact. For example, the plane could not land correctly if the risk occurs. Very high impact, but very low likelihood. So the advice coming from the method PRISMA is to consider that when you have a risk with a very high impact, you will work on this risk. You will put the maximum effort on this risk, even if the likelihood is very low. So I think that's very interesting. You cannot consider that the high-level impact and medium likelihood risks are not that important. The next step will be to build your test approach and your test repository on this matrix. If we consider that the risk with a high level of likelihood will be mainly technical, if we consider that the risk with a high level of impact will be mainly business risks, we can select the test levels and the test techniques applicable to these risks. For example, what we can see here is that when the likelihood is very high, you will put some effort at the lowest testing levels, at the component and integration levels, because the risks are supposed to be very technical, so they will be addressed early in the process by technical guys. On the other side, the risk with a high-level impacts are normally mainly business risks, so the best place to cover these risks will be the highest levels of testing, acceptance and system testing. So that's the first way to use the matrix. Another way to use the matrix is to select the techniques to be applied to cover the risk with the test cases. And this can be done for each test level. For example, first example, at the component level, you will have to deal with technical things related to the software development, to the technical architecture. So you will use mainly what we call white box testing techniques, addressing what happens in the code during execution or during code reviews. So at this component level, you will select the white box testing techniques, like measurement of the decision coverage during the software testing. And you will then decide on the goals regarding the coverage of these techniques. For example, we are working on the software testing. We would like to measure the decision coverage to see how the software is executed and covered during the test execution. If the impact is very high, we will have a very demanding goal, like 90% decision coverage, which is really not easy to reach. And if the impact is lower, it's what we have on the top left corner, we will maybe target only the measurement of the instruction coverage with a low goal of 70% of instruction coverage. And you can do the same at the acceptance level with black box or specification-based techniques. To cover these business risks, you will mainly use black box techniques, and for each technique, you may have specific coverage goals depending on the impact and likelihood of the risk. For example, if the corresponding feature is described with use cases, if the risk level is very high, you will test every possible combination in the use case, normal path and exceptions, alternative path. But if the impact is low, you will just test the main scenario of the use case. So it can really help you to build your test strategy, to focus on specific test levels, to identify the right techniques to be used, and for each technique to decide on the measurement goals of the coverage for the corresponding part of the software. Then, of course, you will have to design the test cases as early as possible in the project, and then to execute the test cases. And to be efficient, you will need to use the traceability. So, of course, you will need a test management tool to manage that. And if you do it properly, you will have links between risks, requirements, test cases, test execution results, and defects. And the goal is to improve and to update your risk repository during test executions. So we should, yes, so it's what I'm going to show you right now. So thanks to the RBT approach, during test execution, you will have the possibility to provide different reports. Let's imagine some of the test cases fails. In that case, you will be able to identify the corresponding risks. And if the test cases associated to a specific risk mainly fail, you will increase the likelihood of the risk. And then you will put more and more effort on the risk. On the contrary, if all the test cases associated to a specific risk pass successfully, you will decrease the likelihood of the corresponding risk. And at the same time, you always have to ask you the question, do I have new risk? And if you have new risk, once again, you have to analyze them and to put them somewhere in the matrix. So that's actually very easy to use, but also you can trust me, it's very efficient. Easy to implement, easy to understand, hopefully, and very efficient. What next? Well, I hope, if it's not already the case, that you will try to use it. And if you want to get more information about that, you have, firstly, the book describing the method. We only see the cover on this page, but don't worry, it's a very small book. It's about 70 pages, like this. It's not the huge software testing book. Very easy to understand, very clear, with many examples. So I strongly recommend to ask this book for Christmas. Yes. If you want to make the method easier to do, you can tool the approach, either with your own Excel files, and there's also a PRISMA tool available on request for free, easy to use. It's like an Excel sheet with macro supporting the whole approach. And risk-based testing is something which is absolutely mandatory. It's everywhere. If you want, for example, to get ISTQB certified, you absolutely need to have a minimum knowledge regarding the risk. It's everywhere in the documentation. If you plan to have your organization assessed against TMMI, for example, you absolutely must manage the risk from level 2. It means that risk management and risk-based testing is really considered as the basic that you must put in place in your project. Okay, so that's about it for today, about risk-based testing. Thank you for your attention.